One of the reasons I made some updates is because this lesson in particular and the challenge have historically received a lot of complaints from students for being a bit challenging. So with a new demonstration, I think this should make the challenge a little more palatable. And I think Omer told me that you all had some challenges from last night that you haven't finished. So if you are able to get through today's challenge a little earlier, you can go back to working on those. So yesterday you covered HTTP clients, and then over the weekend we covered APIs. Can does anyone want to take a stab in their own words, describe the relationship between servers and clients?
Server stores the data, client receives the data.
Yeah, it's a very succinct way of describing it. Apparently, we also asked ChatGPT, and its answer was that in the context of a web application, a server is a computer program or machine that handles requests from client devices, and such as web browsers, and it sends responses back to those throughout a network. And so that is going to be one of the key things we talk about today, the requests versus responses. And I mentioned on Saturday how when you are making any kind of HTTP request, those are the two components that you're always going to have, a request and a response. Even if the request fails, you'll receive a response with the error message most likely as to why it failed. And before we go any further, let's also just real quickly think about how, in contrast to a client server network, there are other ways to connect devices, P2P being one of the other most common ones. But the key difference between a peer-to-peer connection and a client server connection is in a client server connection, the roles are designated. In a P2P connection, both every machine is capable of being both the client and the server. They could both send and receive requests. But in a client server network, these roles are designated to specific machines. And most of the public web interactions you go through on a day-to-day basis fall under the client server model. And that includes, email, web browsing, file downloading, etc. Because in all of these scenarios, you, the user, are connecting to an external location servers. And so whatever device you're using, be it your mobile or laptop, your browser, or an application on any of those devices, that is the client. So client requests and server responses. In particular, what we really want to talk about today is the protocol for these two components because they have to conform to conventions. So there's consistent and predictable behavior. With an HTTP request, you're always going to have a request line, and that includes the method that you are specifying. So we saw that when we were running this in Postman, you are selecting, I don't know if I'm still signed in. You are selecting the method by which you want to make a request. And when we are doing this in curl, it's the same thing. Well, let's make a new request. Yes, you're able to switch between different methods. And in curl, when you pass in the -x option, you could specify as well which method you want to submit the request as. And in addition to that, you are passing in headers, which will essentially contain metadata, such as the client's user agent, the content type, basically if the data type of the content is HTML, JSON, etc., and a body, which is optional but is necessary for APIs that require some kind of input from the user, specifically any kind of post request, for example. You, yeah, well, I can't say that. I guess I wouldn't say that every post request requires it because I can imagine that an endpoint can be created to accept post requests without a body. But the general use case for these kind of requests, because you're trying to post data or more accurately, insert new data into like a database, for example, you're very likely going to be passing information, and that's going to be through the body. Now, the HTTP response, this will include the status code. And so when you're troubleshooting various status codes, because of the way that they are separated, what a status code starts with will already give you a lot of information. Any 400 status code, for example, usually relates to like authentication issues or some kind of a blocked connection. 200 responses are usually successful, and 500 responses are usually some other kind of error, such as the server being down and unable to process that request. So again, even if the request fails, there should almost always be a response. Like I imagine the only instance in which there wouldn't be a response is if the request doesn't really send out at all. Okay, so just like the request, the response will have headers and a body, except in these cases, the body is going to be specified by the developers that are programming these API endpoints, and the header will be returning information about the server. All right. Any questions so far? Cool. All right. So we talked about curl. We are actually, yeah, let's do this real quick. We are going to just run a simple curl command in our terminal and show how by passing in an option -v for verbose, we could get more information that we normally would, right? So if we were to do a curl request for example.com, it would simply just return the contents of that index.html that we hit. Now, let's do that with the verbose flag. Now we have all this additional information. And basically, this is the protocol that we were talking about a little earlier. These are essentially what you can count on always being there whenever you are interacting with either a request or a response. You will always have, for a request, a method and an endpoint. In this example here, the endpoint is simply a /, which when following the URL is essentially just saying it's the root directory of that URL. And then it's showing the content type that's being sent back. And in our case, it is HTTP. And then we have the host or a URL for the host listed next. And it also tells us what kind of method is being used to make this request. And so we made this request using curl. And accept will essentially refer to the various types of data that can be accepted in a response. And so we will accept anything as a response, be it HTML or JSON. Now, the response itself, similar to the request protocol, it's letting us know uh, what we're trying to hit and what kind of response code we're receiving. So a 200 is an okay, right? And it's also going to let us know how um, old this response is, or more accurately, like the time gap in between when the request was sent and the response was sent back. And then a lot of other information that we're not really going to be too worried about today. So things like the date when this was sent, for example. This is all pretty regular. When you are reading through a response and troubleshooting, like for example, if you were to get like a 400 error or something along those lines, some of these details might be able to help you um, troubleshoot. Like if you were reading through logs that collect a bunch of these, naturally knowing the time that a request was sent will allow you to filter down where in the logs you want to actually look. And so let's see, most of this information is optional and will vary depending on the server that's responding to your requests, because it really boils down to how the code on that server is programmed, written to handle your request and respond. Okay. So some common formats that you will get both as the body in a response and the body that you would be sending out through a request would be HTML and JSON. So if we wanted to run this command, we can see a JSON response. So let's grab that terminal again. And with the verbose flag, we see now that we have a different URL, and we have the same information we were seeing before, which is like what kind of component this is. So it's like this is the request, and then we have the response below it. We have a 200 code for the response because it was a successful request. The server was able to receive it, and the server was able to respond. So in today's challenge, you are going to be troubleshooting a very simple server. And part of troubleshooting that server is going to require being able to look at the protocol that is generated from a request. So when you make a request, if you use this -v argument, that should give you the information you need to get through the challenge. Let's see. And just to give you some familiarity with a bit with servers, well, I guess a very simple web server, we're going to create a very simple one ourselves, straight out of a Python script, out from scratch using Python. So if you have your terminal open, go ahead, create a new folder and a new file. You just call it server.py. And let's talk through what this is before I demo it. We are importing some modules, CSV, because we're going to be working with a CSV. What we're going to do is essentially mock the behavior of a GET request. We are going to get data from a CSV file as opposed to a database, because we don't need to set up an entire database just for this simple demonstration. We're then going to want JSON, because we definitely want to be able to parse some of this data. And we're going to want socket. Socket is the module, the built-in Python module that allows us to establish the connection between a server and a client. More specifically, it's what allows us to bind a listener to our server so that it could listen for requests from an incoming client. And you could think of socket as being like a route or a pipeline. It's basically just like in the physical sense of the word, a wall socket, you're plugging in something into a wall socket to transfer electricity. This is essentially the same thing. This socket allows for the transfer of data between two different systems. And first, we're going to need a class that can handle the request. So every time that we receive a request, it's going to instantiate this class. So we have a simple init, and we are going to run a method, parse request, on the client socket that we receive. And there's a series of methods being run here to convert the data that's being received into a more mutable, manageable format for our script. So once that's converted, we can pass it into our parse request method. And what we want to do with this method is create a request line so that we can actually see in our client terminal the data that we're looking at. So we're basically taking information um, that exists with the server, which we'll represent with one terminal, and we're sending it over. We're parsing it and then sending it over to the client, which will be represented by another terminal. And so we're running a few different functions on this data, like running a split and running a strip on this forward slash. We'll see in the terminal what's actually happening, and that'll give you a better idea of what's going on here. But for now, just copy paste this into your server.py. Next, we want to have the functionality for endpoint interactions. So in our case, we're just mocking a simple GET request, right? We want to get data from a database. So we're going to need a read users method. We're going to need a find user method as well. You can copy and paste these two, but be mindful of how you do that because we don't want this inside of the class. We are going to want this indented all the way to the left outside of the class because it's not the request that's going to run this logic, right? It's going to be the server that we want running this logic. The server receives the request, and based on that request, it's going to run some built-in logic. Now, this is where we set up a connection, and I added a lot of notes here because it's essentially a lot of Python module magic happening behind the scenes, right? So we set a server and we set it to essentially something that we're calling out of the socket module. So we call the socket module, it's got its own function that's also called socket, and it just takes some of this built-in information. Again, stuff that we don't really need to know, but just to talk through it, that's what's happening. And then it's essentially going to take all of this and bind it to an address. This 0.0.0.0 is basically a representation of being able to allow all IP addresses. If we wanted to only allow a connection to and from the local host, we would use the local host address, which is like 127 point, et cetera, et cetera. And this second value here is the port number that we want to open. This is the port that the client will need to send the request through in order to hit the server. And let's see. right? So just going back a few steps. Again, this
There-
Python, sorry, what was that?
I have a question. So that port,
Hmm.
is there a setting that we need to do on the firewall to open it or not? Or it's just gonna be open automatically or what?
Yeah, it's we're gonna run this script and it's going to expose that port to any uh IP address because we're using 0.0.0.0. All of this is going to be happening on your local machine.
Yes,
Okay.
that's what I mean. So if it's how would it override? It's a loop back. Okay. Okay.
Okay,
Got it.
cool. So let's see. Right. This first line creates the socket. The second line essentially reuse address. Um, it closes the connection after a request has been made so that it could restart it immediately and accept new connections. So that's really all these two things do. Again, not something that we really need to know or are too concerned with. And now the final part is going to be this loop because it's going to be in outside of the class, it's going to be global, right? So as soon as we run the script, this logic is going to run and it's going to repeat because it will always be true as long as this script is running. It's just a simple way to create an indefinite loop. We're going to grab our server that we created. We're going to call the listen function. We're going to print a friendly message in the terminal so the user knows what's going on. And we are then going to set, we're going to call the accept function and we're going to set that to a variable called client socket. And then we pass that client socket to our request class. So we're instantiating the request with this client socket. And then from there, we can interact with the request. We're also going to call this read users method that we created earlier. So we scroll back up to that. Read users is going to grab from a CSV file and it's going to read through it. And then based on the request, which again has some logic to parse um, the request that we sent in and the protocol that's I guess traveling with it, we'll be able to then grab that, use that protocol to render a response for the client. And so it's again a lot easier to see this in action. Trying to explain it in words is can be it's a little abstract, right? So let's go ahead and run this. I've got this in this directory here. The way we run it, because it's a simple Python script, is just using the Python command. So Python server.py, and now we see that print statement that we had, right? And with now that we have an active, it's running, it's essentially in the middle of this indefinite loop and it's waiting for a response, we can go ahead and hit this server with a client. So open up a new terminal, ideally side by side, and that new terminal is going to act as your client. Server on the left, client on the right, in my case. And now we can run a curl request. We're going to run it to our local host because we're sending it. This is all happening on our local machine. And we're going to specify the port that we opened, 9295. And then we're going to hit an endpoint. And again, in this case, we wrote that endpoint ourselves, right? We wrote it here in this line. We're basically saying if once we parse the request, the protocol, if we see the / users in that protocol, then we will want to do the following. So let's do that. Let's hit enter and you should receive a response. So what's happening? Because we see the users in the protocol, this logic executes. We use JSON.dumps to grab the values that we've retrieved from the CSV, and we create a response using that. And then we run an encode method on that response, and we just send it back through the client so that the client can receive it. And if we do this one more time, well, actually, before we do it one more time, let's go ahead and like send it with that endpoint. In that case, we hit this. We could actually add to that as well. Let's see, is this the right one? We could add to that and say something like, if we use this point print bad endpoint not found, something along those lines, right? And so if we find demo 0, let me exit out of this real quick. Py, don't have the right file. Oh, it was here, okay. If I grab this print and I toss it in here, and I save, and then I rerun my server, and then I try to hit like a bogus endpoint. Now we see the print statement server side. If we wanted to see it on the client, we would have to send it. Now, if we do a verbose, however, on the bad request, we see this message that we are in fact sending through the client. So that is requests and responses and the protocols that they follow. Again, one more time, if we do the verbose on the successful request, the information we see here is where the and the kind of method that we are sending. By default, curl will send a GET request if you don't specify what kind of method you want to use. And then we see the endpoint that we are trying to hit. That follows the URL that we are trying to hit. And that's pretty much it. If we go back up to what's happening here, where we're parsing the request, this is why we are using things like decode to decode the information, the data type of the information that's being passed in. And then we're using split, and we're using split again here. We're actually just grabbing this protocol and we're breaking it down, right, into manageable, not really manageable, what's a better word? The chunks of information that we actually need, right? So this, for example, if we wanted to know the specific method that this request is using, then we can use this logic to retrieve just that. And then this URI, because it's splitting after every space, is grabbing this endpoint. And then we're stripping any trailing forward slashes at the end. So if we were to do users forward slash, it would still succeed. Any questions?
What is coming from the socket library?
Sure. So a few things are coming from the socket library. Basically, this is what establishes the socket. It's like what's instantiating that connection, right? And with that socket object, we could call functions like accept and listen. This here is basically a command that will reset the connection immediately after a successful interaction because otherwise there would be like a delay. And then this last method here is what allows us to open up our server's IP address to a specific port that we want the client to specify when they're making the request.
So I'm trying to understand what Socket's doing. So let me see if I can try to. Socket's creating like a gateway for you to get into the server.
Yes,
That's
yes,
what why it's important. Otherwise, we wouldn't be able to create a port, like open up a port or essentially a gate for us to get in there, utilize the while method and everything to grab the CSV file, and then bring it back to us in our other server here, our other terminal.
exactly. Yes.
Okay.
Cool. All right. Any other questions?
So how do we do authentication?
That's a lesson for another day. Okay, cool. So let's go back here. Yeah, today's challenge is pretty much the same thing. It's HTTP server. You're going to have a server.py and you are going to try to get this to work. It's going to break in a few different areas. And so utilize your curl commands with the verbose flag to incrementally make your way to the solution. And once you're finished with that, like I said earlier, I think Omar mentioned there were some challenges that you weren't able to get through last night because yesterday's lesson had a lot of content. So if you finish early, just go back to that. Sound good? Cool. I'll open up breakout rooms and we could take a break and we'll reconvene at 9:15.